little warm up. So yeah, here we go. Some exercise warm ups. All right. My shadow's blocking. Okay. Anybody else? Let's see. Anybody out in the crowd? You're too far away. All right, let's just get started. All right. So let's shut this guy down. And we'll start my little node process here and get to some slides. So this is my favorite part of the thing. So run right over. Hey, we're sweating to the web. We come right in. So yeah, this is called Sweatin' to the Web because we're gonna move around. We're gonna move our bodies to the web. My name is Ben Farrell. You can catch me on Twitter at bfarrellforever. So I'm having a fun time with all this stuff. So let's get going. So about me, hey. I like to call myself a creative developer. I just got why you were clapping. Thank you. The gestures, yes, I've been practicing these to make sure they went okay, and yes, thanks for the applause. But I like doing like fun, interactive experiences, games. I like whatever happens, and sometimes that happens. Hello. So I like doing fun games and interactive experiences, and there we go. This happens when you're up on stage. So what I wanted to get started with is in the 80s, we were all sitting on the couch. This is the typical scene from the 80s, sitting around eating snacks, being generally like kind of fat and lazy. So yeah, we were really lazy. This only happens when I'm on stage. So here's another picture. Al Bundy, he's really lazy. Again, typical 80s stuff. Just being lazy, sitting on the couch, eating snacks. No good. You saw it happen. I did it. But then something awesome happened. So TV has always been a sit-down medium since the 1950s when it was just kicking off. And the obesity crisis was just getting started in the 80s. You know, my parents were like, no snack food, no junk food. We're gonna ration your TV time. You can't watch DuckTales. You can't watch, Batman and stuff. But, it was largely blamed on TV and snacks. So what happened that was so awesome? It was the 80s fitness craze, and we had this TV, it had been inactive since the 1950s. Richard Simmons, he transformed it. We took this inactive medium. I wish I could gesture, this sucks. So instead of sitting on the couch, Richard Simmons and friends, like Jane Fonda and people, they got us to clear a space on our living room floor. And we did some cardio, so we took this inactive medium and we changed the way we watch TV for the better. But at the same time, we had a Nintendo taken off. Nintendo wasn't the first game console, but Nintendo popularized it with Mario and everybody. So we had that medium taken off, but guess what? It wasn't any better. Gamers, you were sitting in front of that thing and you had a TV and like using your consoles, reaching into the bag of chips. It wasn't any better. But maybe it was, because hello. Nintendo came out with a power pad in 1986. It wasn't that popular at the time, but it put the buttons on the floor and let you dance around a bit and got you moving by just placing those buttons in different locations. So that was great. How is it? Thank you. Now it's finally working? All right. Dance Dance Revolution. Guys, this isn't funny. Dance Dance Revolution, 1998, it really took off the game pads on the floor. So it was really taking off. Japan got it in 1998 first. Really popularized this because we had music and we had dance, unlike Nintendo's 8-bit days when we had like really weird characters moving around. But at heart, game controllers, they were just funny looking things with buttons that were displaced. I mean, you think about Guitar Hero, The buttons are just on the fretboard. They're the same controller buttons we've already had. Same with Dance Dance Revolution. They're just displaced. I won't lie to you, it's incredibly fun using these things. They're awesome to play. And the experiences we had were just fun. So, you know, Nintendo, you know, they took this and kicked it up a notch. So we have an accelerometer built in, so you know I can tell the orientation of where I'm putting the controller, and it had an infrared optical sensor, so I can point at the TV and like figure out where it is on the screen. It also had the button smashing buttons and directional pads, so I can still play my same games. And you could move around a little bit. So we're getting there. Wireless connectivity via Bluetooth. No wires anymore. Awesome. I always try and I always fail. It only works when I don't want it to work. So then Sony came along, and guess what? They had the Eye and Eye toy for PS2 and PS3. So they took these cameras. They're just normal web cameras. They don't do anything fancy, but they hooked them up and they did some computer vision stuff. I'm not that familiar with computer vision stuff, but you know, they had edge detection, face detection, pixel tracking, head tracking. And they also had a 4-array directional microphone, or a 4-array microphone. So not just having like 4 microphones, you could tell, hey, a user's over here, or a user's over here, or you could cancel out some echoes around the room, and you could get rid of background noise. So everything was a lot more clear with 4 microphones with different sound sources coming in. And then, you know, the problem with web cameras is living rooms can get dark. Where we're playing can get dark. And you know, there might be weird lights all over the place that shine up and cause lighting to be weird. So what Sony did was they put LED balls. They put them on the tip of the controller, and they lit up a different color for every player. And the size and the position, it still uses computer vision with a simple web camera, but they give distance and motion, and you know better where they are, especially in a dark room. And they also built in an accelerometer, just like the Wii, for you know, rotation and improved motion data on that controller. So things got better. They're starting to get more active. All is cool. Now, Microsoft, they came onto the scene. So they have the typical RGB camera. They have the typical 4-array microphone. But what they added to it is an infrared depth finding camera. So let's look at that a little bit. But I digress because we're talking about consoles here. We're all web developers. So let's think about this a little bit. Kinect, I think it was in 2010, they came out with the Kinect for Windows SDK. And they support application development in C#, blah, blah, blah. There's bindings for, there's this project on the scene called Kinect.js. It was pretty cool. It created a Flash and Air WebSocket server and sent all that web data over to JavaScript through a WebSocket, and that's how Kinect.js works. So it's a cool project, and I tried it out. It was a good time. The official Windows SDK, it costs $250. But the not-so-official kit, you can get one for $100 or under. And that's what I call poor man's Kinect hacking. So you can get an Xbox Kinect, and I found one online for like $70 used. And you have to get a $10 USB splitter for the power supply. So you're connecting with USB, you're connecting with AC adapter. The Windows SDK works great on this. It's not legal for commercial use though, so that's the thing. That's how Microsoft gets you on this. And they also lack the firmware to give you a proper near mode. So if you get really close to the camera, it's not going to necessarily work properly. But again, I digress because we're web developers, right? So how can we get around this? No Microsoft. Or maybe some Microsoft. I don't mind Microsoft, but I'd rather not be all Microsoft. So open source, awesome. Open source library for 3D sensing, OpenEye Foundation. They call themselves the standard framework for 3D sensing. They are cross-platform, so Ubuntu, Linux, OS X, Windows. It also works with the Kinect, but that scenario is Windows only, unfortunately. However, if you get a camera like I have, this small guy right here, that's an Asus. It works with those other cameras. I'm running this on Ubuntu. It works on OS X, works on Windows, cross-platform goodness. It's awesome. So, like I said, Asus XJohn Pro Live is what I have. There's also the PrimeSense Carmine, and PrimeSense was the original people that came up with this technology, licensed it over Microsoft for the original Kinect. So you can get those for $119 to $200. It's smaller than the Kinect, no motor. So like the Kinect has a motor and it can follow you around the room really creepily. No extra power supply is needed. I'm not plugged in via an AC adapter here. I just plug right in USB in my computer. All is well. Some of these guys don't have microphones. You can use your own sound setup. That's fine. Yay, working again. So not so open source. Oh, did I skip a slide? No, I didn't. OK. So there was OpenEye, and that gave you cool depth finding data. 19 minutes. All right, exactly what I have. Not so open source. So there was the OpenEye stuff. And that gave you depth data, so like how far everything is close to the screen. But we got some middleware, and a lot of people are making middleware for this. One of those people is PrimeSense, so they're trying to get this out there, and they give you skeletal tracking, user detection, and a few gestures. So that's cool. However, you know, it's all still C++, but let's take a look at what these cameras do first. So if we're talking about a normal web camera, you know, the PlayStation Eye, they'll typically use edge detection. So if you go into Photoshop, you can take a look at, you can use edge detection on a photo, and you can get the edges. And that's kind of how these, to my understanding, that's kind of how these places, you know, they'll do gestures and object tracking and whatnot. They'll get the edges and work from there. So, but an RGB plus D camera, depth being depth, they'll get all the depth data. So the lighter stuff is the closer to you, the darker stuff is farther away. And you know, behind the scenes, if you put on infrared goggles, you could see tons of beams shooting out at people. And that's how the beams will shoot out at somebody or an object in the background, bounce back to you, and that's how they see. And that's why like in this slide, you know, it's not very fine-tuned. It's kind of sketchy. It's kind of blurry. So that's what's going on there, because these aren't very small infrared beams, so they're not very fine-tuned for performance here. But it still works because you can interpret that depth stream. Get, you know, my hand is over here, my hand is over here, my torso is over here. So you can get full skeleton control for this. But again, I have to digress because we're talking about C++. And yeah, we'd probably rather be stuck on C# on Windows. But luckily, I can make a plugin for this. And I made a NodeJS plugin. So hopefully now we can get cracking Sweatin to the web. So it's actually on NPM, NPM install, new emotion. I have it on GitHub right here. So my point in here is not to sell anything or anything. Like, take it, learn from it, break it apart, fork it, whatever you got to do. I just want to see cool experiences on the web using browsers and Node.js. So an example of what we can see here is, you know, I can go in and start a skeleton listener. So I add a left hand, a right hand. I add a callback at a certain interval, 50 milliseconds being my default. And I can take a look at, OK, in my callback function, I'm getting a parameter, my skeleton. I get x, y, z coordinates for any joint I want, x, y, z rotation for any joint I want. My hand being 100% extended, being not extended at all. So there's the kind of things you can get if you look at the skeleton. So you know, it's fun stuff. It's really fun stuff. And event listening, I can see, oh, is my user out of the scene? Or if it would do that. There we go. All right. So yeah, when my user's out of the scene, when it stopped tracking, when it started tracking, all that good stuff. And I can listen for gestures too. So swiping down, up, left, right. I can figure out a wave on my hand. Yeah, so you can write. I'm writing my own gestures, and sometimes they're not very good, especially in situations like this when things are going crazy. But I like the skeleton stuff myself the best. And uses, it's really fun to use. And other than that, you can create cool 10-foot interfaces. So like the Xbox, you're sitting on your living room couch and you're controlling an interface with your hands. There's also innovative games, using your whole body to get out and make a game. Interacting with public spaces. How many there's so many touchscreens out there, and they all get smudged up and greasy. What if you could create some public space interactive experience where you don't have to touch a screen? You just use your hands in thin air. Real world analytics. This is a cool thing that somebody did, a cool application. So there's a company called Shop Reception. Shop Reception, I would have never thought of this. They mount like a couple Kinects or whatever cameras on top of a shopping aisle, and they look down on people, and they gather real-time metrics on when people take stuff from the aisle, stuff from the shopping display, and they'll get heat maps, they'll get analytics data. So this is something I would have never thought of, and people are doing it with these cameras. So it's like a real-life Google Analytics for you. But here's what I don't want to do, and there's a book called Brave New World, and it's about we're talking about natural user interfaces, and natural user interfaces are the type of thing where you're interacting with something very naturally, not using a mouse and clicking around. Just walk up to something and figure out how to use it. And I stole this from their book. They made a great little point. So we all wanted power gloves back in the 80s when we were kids. At least I did. Did anybody have one? Yeah, like 2 people. So, and why was that? I mean, I don't think my parents wanted me to buy one, but the reason they were a failure was there was like 2 Power Glove games ever made. They could also be played with a standard controller. Therefore, you didn't see any user experience innovation on these games. It was just an awkward controller you use. It looked so cool, but at the same time, what are you getting out of it? Kind of nothing. So the author of this book kind of says, why bother with this when you can try other things? And I kind of put the connection in my brain to kinesisio. Kinesisio is a project started last fall or summer, and they came up with this cool thing with the Kinect. And you could take div tags and mark them up with special CSS styles, and mark them up as interactive. And what it would do is go through your DOM and look for these things and say, hey, this is interactive. I'm gonna make it, I can click by putting my hand up in the air and holding it there for a while. So that's how I click links. I can scroll around on the screen. I can use a cursor. So all cool stuff when you think about it. But if you really think about it, why bother? Because we already know how to interact with a web page, and this is kind of an awkward way of doing it. I don't mean to be disparaging of these guys, but maybe we could create better experiences with these new natural user interface tools we have, the hardware. So, that's my why bother. So like I said, we're talking about natural user interfaces. They should, to reiterate, they should really be intuitive. We're talking about gestures, we're talking about motion, we're talking about speech. 2D gestures are already on all your mobile devices. You can pinch, zoom, flip photos. And guess what? Speech is also a form of natural user interaction. We're talking to our devices now. So we're talking to Google now, or we're talking to Siri. And so some rules, people are already doing this stuff, especially on Xbox, and Microsoft is already coming up with some rules for this. So one of those rules for games use the game mindset. In games, people like being challenged. They don't mind looking a little silly, like I'm doing with all this stuff. And they're eager to learn, they're eager to improve. But for applications, if I'm using a slide deck, for example, I gotta walk right up there. I gotta start using it right away. I don't want any guidance, no learning curve. I want my app to be immediately functional, or people will just not want it. And I have some gesture guidelines that I was going along here. So what you want to do is create a good balance of intuitive and intentional. So when I say intuitive. I mean, like I said, I want to walk right up to something and I want to start using it. I want to know what's going on. And intentional means, my gestures haven't been working out well with you guys here, but, I don't want to do anything accidental like I have been doing here with you guys. So if I start getting really excited about all this stuff, I don't want my stuff to go off and advance the slide. So you got to strike a good balance there with your gestures. And I want to see gesture progress. So when I raise my hand here, you can see my gesture starting to start. And then I can see it cancel. So I have some good visual feedback there. When my arm's getting raised, when I'm ready to go and do a gesture. So I have some progress steps in there in my plugin. So yeah, I'm hoping you guys try it for yourself. Like I said, take apart my plugin, learn from it, whatever you want to do. WebSockets are probably the most obvious way to use this technology. So what I have is a plugin for Node, the new emotion plugin, and what it does is just connects over WebSockets and sends data to the browser. And like this guy is a Reveal.js, obviously, and I have a plugin going in Reveal.js to pick up this data and listen for gestures. But another cool thing I found was making a desktop application with app.js or Node WebKit. So Node WebKit takes it takes your Node project and slaps a WebKit front end on it and bundles it all up on one project. And I tried that with this, and it works great. So check out Node WebKit. I have some links at the end for this. And then, the other reason I want to check this out is because OpenEye, the foundation, they're a little biased, of course, but they project a $15 billion 3D sensing industry by 2018. It's a little far in the future, but I like to get in on the ground floor and stuff like this, so and start playing with stuff just because it's fun. And PrimeSense, the company that makes some of these sensors, they're being sold in bulk to device manufacturers. So you'll start to see them in smart TVs. You'll start to see them in smartphones, all over the place. So I think it's a cool thing to try as web developers to get out there and start. Even if my plugin, who cares? But if we can start experimenting with ways to do this stuff on the web and start experimenting with innovative ways to get all this stuff going, and I think we can get a jump start on this. So yeah. So here's some links. You can find my manifesto on all this stuff on sweatintotheweb.com. Here's my GitHub repository, and then my website, and then Node WebKit, which I mentioned for wrapping all your apps up as a whole package. So yeah, that's my presentation, but I wanted to show you guys a quick little demo that will traditionally work better than this one. And I think everybody I talk to when they do stuff like this, they're all over the painting demos. So I made a little painting demo. Let's see. And I also, let me switch it over to HTTPS because I wanted to use the Google Chrome 25. They have a Web Speech Kit API in there. So if we switch it over to HTTPS, it can always be on and always be listening to you. So let's see if it can hear me. I hope it can. Maybe the mics are weird. But so we're gonna. So I have some my painting in here. So if I keep my hand in like this, it's not painting. But when you reach out your hand, which I think is a good, nice way of telling it you want to actually do something, it starts painting. And so we can paint along, and then we can start erasing things. And like I said, bring your hand in, and it doesn't do it anymore. You're just going around the screen with your icon. So we can start painting. And if I shout at this thing, so let me hide the mic. Give me a purple paintbrush. I think the sound is weird on that one, but so yeah, that's one thing you can try to do with the skeleton data. Since I have a few minutes left, let me show you guys another little demo here. So here's a little demo where you start out as an egg, and then when you get on screen, it should hatch. Let me refresh. There we go. Starting to hatch. Come on, pick me up. Oh, no. OK, there we go. So magically it hatched. I know you guys, you didn't see it or anything, but let me. Yeah, OK, so we're back to an egg. So when you go in front of the screen again, oh, come on, seriously? Let me start that. Oh, Jesus. Only happens when I'm up in front of you guys. All right, come on. There we go. So the interaction mechanism here is we're seeing the rotation of each arm, and we're controlling the bird's arm was that. And the physics on this are really wacky, and I have to tweak it. But you can start flying away. And if I get high enough, I can start floating down. And I think my computer just died. That was really rough, so I'm going to have to put on my extra sweatband here. Thanks, guys. Much appreciated.